Welcome once again. So far as we have discussed about the basics of mechanics of machinery, then what are the different parts of a mechanism, then what is meant by link, what is a pair, and what are different types of kinematic pairs. Then we came across the types of constrained motions, and finally we have studied the concept of degree of freedom. So now we will discuss what is kinematic chain. So the previously studied things are required if you want to understand the concept of kinematic chains. So it's an assemblage of links and kinematic pairs capable of relative motion. That is, it's an assembly which consists of links, number of links and pairs which are connected together and which is capable of having a relative motion. That is a kinematic chain. And the criteria for obtaining a kinematic chain is last link is joined to the first link. That is another important criteria. Last link must be connected to the first link. That is a kinematic chain. So let us see this example. Here we have four link. It's a four link or four bar mechanism. So AB is one link, then BC is the second link, CD is the third link, and AD is the fourth link. So we have four links, and how many pairs are there? So we know pairs are formed when one link is connected to another link. So here we can have one pair here, that is at point A, that is one pair. That's a turning pair between link AD and link BC. Then there is another pair at point B where two links are connected. Then again there is another pair at point C where link BC and CD is connected. Then we have the fourth pair at this point D, which is where link AD and CD is connected. So we have four pairs or joints. Pairs or joints means the same. So we have four link and four joints or pairs. So it's a four bar or four link mechanism, and it is having four pairs. So that is this particular mechanism. So here you can see, if we consider AB as the first link, then BC as the second link, then CD as the third link, and AD as the fourth link, then we can see that the first link and fourth link is connected. That is, first link is AB and fourth link is AD. These two are connected. That is the condition to form a kinematic chain. That is, the first and last link must be connected, or first link must be joined to the last link. That is the criteria. So this is what is a simple kinematic chain. So now we can say that a kinematic chain has been formed. That is what is kinematic chain. Now there's a condition to form a kinematic chain. So we are having a relation between the number of links and pairs so that we can successfully form a kinematic chain. Now we will discuss that particular equation or criteria. So if each link is to form two pairs with two adjacent links, then the relation between the number of pairs, that is P, forming kinematic chain, and the number of links may be expressed as. That's a relation between L and P. L means the number of links or number of bars, then P means number of pairs or number of joints. So in order to form a kinematic chain, we have to satisfy this particular relation, that is L equal to 2P minus 4. That is the equation or criteria to be satisfied to form a kinematic chain. Another expression, we also have another expression between the number of links L and the number of joints which constitute a kinematic chain is given by J equal to 3 by 2 into L minus 2. So that is another expression, that is between the number of joints and number of links. So these two equations must be satisfied to form a kinematic chain. Now let us move to some more definitions. So far as we have discussed the kinematic chain, we started from the link. Then link is having nodes at the ends. So depending upon the number of nodes, links are classified into binary, ternary, and quaternary links. Then when two links are connected, the nodes, it forms a pair or a joint. Then depending upon the relative motion possible for the pairs, we have classified the pairs into sliding, rolling, revolute pair, screw pair, etc. Then we studied the kinematic chain, that is when links and pairs are connected to form a kinematic chain. The condition is the last and first link must be connected. Then we came across the criteria to form a kinematic chain. That's a relation between number of links and number of pairs. So now we will see some more definitions. So we have studied up to kinematic chains now. Now next one is mechanism. So from the kinematic chain we will generate the mechanism. How we will generate the mechanism we will see here. When one link of a kinematic chain is fixed, then the chain is known as mechanism. So primary function of a mechanism is to transmit or modify motion. That we already studied. The mechanism is used to transmit or modify motion. So we have already seen the kinematic chain here. This is a kinematic chain. So if any one of the link, that is either AB, BC, CD or AD, any one of the link of this kinematic chain is kept fixed, that forms a mechanism. So we have to fix any one of the link of this kinematic chain, that will form a mechanism. So different links can be alternately fixed to get different mechanism. First we can fix link AB, then we will get one mechanism. Then if we fix link BC, we will get some other mechanism or some other motion. Then if we fix the link CD, we will get some other motion. So like by fixing links alternatively, we can obtain different types of motion. So that is a mechanism. A mechanism is formed. That is what is a mechanism. So mechanism, we have a simple mechanism, that is 4 links. So every mechanism, the minimum number of links required for a mechanism is 4 link. So so that's called a simple mechanism. Then compound mechanism or complex mechanism may have more than 4 links. So usually most of our common mechanism like a slider crank mechanism, cam and follower mechanism. So these mechanisms are having 4 links. So that is a simple mechanism. If there are more than 4 links, that become a compound mechanism. Then next we have to determine the mobility or degree of freedom of a mechanism. So we already studied what is degree of freedom. So I already told you when a link is independent, it can move in all directions. It can either translate along XYZ direction, and it can either rotate along SYZ direction. That is, it has got 6 degrees of freedom if a particular element or a link is placed in space. So when we place that link to a particular surface and constraints its motion to move only along the surface, then the degree of freedom will get reduced to 3. That means it can either move horizontally along the surface, or it can move vertically along the surface, or it can swing over the surface. So that is degree of freedom has been reduced to 3. Now the third case, we already seen the third case, that is when 2 elements or 2 links are fixed to form a pair, there comes some constraints. So the 2 elements cannot move independently, so they can move only relative to each other. Then that will become, one of the link is fixed, that will become a mechanism, and that mechanism will be having some other degree of freedom which is not related to the which is related to number of links, number of pairs in the mechanism, etc. So that is how now what we are discussing the equation for finding out the degree of freedom of a mechanism. So when the kinematic chain is fixed, one of the link of the kinematic chain is fixed, it forms a mechanism. Now we have to see what is the degree of freedom of the mechanism. So that is that can be found out using the equation that is called Pushback equations. So in a mechanism, rigid bodies may be constrained by different kinds of planar pairs. That is, the movement of the mechanism is constrained due to the presence of pairs between the links. So if n is the number of links including the frame means the fixed number. I already told you, if you want a mechanism, we have to fix any one link of the mechanism kinematic chain. So that is called as frame. So if n is a number of links which is including the frame, then p is the number of binary lower pairs or simple hinge. That is, p means number of lower pairs. We studied lower pair and higher pair. What's lower pair? Lower pair means when 2 links or elements are having surface contact, it forms a lower pair. Then if higher pair is there, what is higher pair? When 2 elements are having point or line contact, it forms a higher pair. So here p is the number of binary lower pairs or hinge. That is called simply hinge. Then f is the mobility or degree of freedom of the mechanism. So this is the equation. The equation is given by, you can see the equation here, that is f equal to 3 into n minus 1 minus 2p, where f is the degrees of mobility or degree of freedom of the mechanism. N is the number of links which is including the fixed link. Then p is the number of lower pairs. So if there are only lower pairs, that means the pairs are having surface contact. If there are only lower pairs in the mechanism, then we can use this equation. That is f equal to 3 into n minus 1 minus 2p. That is one equation. Then if the mechanism is having higher pair also, that means I already told you higher pair means if some two elements or two links are having forming a pair, and they are forming a pair such that they are having point contact or line contact, like the cam and follower case, the cam and the follower will be having point contact, so that will be coming under higher pair. So if there are higher pair also in the mechanism, we have to modify the above equation. That is, the equation will be this, that is f equal to 3 into n minus 1 minus 2p minus h. Another time h will also come into picture, that h is number of higher pairs, that is f equal to 3 into n minus 1 minus 2p minus h, that is degrees of freedom of the mechanism. The equation 1 and 2, these equations 1 and the last equation was 1, this equation is 2, this is known as Pushback equations. Now we have another criteria which is called again for determining the mobility, which is called Gabler's criterion. So that is for single degree of freedom joints. So if two links having single degree, that is f equal to, here we have a term which is f. If that f is 1 for two joints, or for a pair, if f is 1, that is degree of freedom is 1. We know that degree of freedom is 1. It can move only in one plane, or it can have only one degree of freedom. Then we can use this Gabler's criterion. That is, if we put f equal to 1 in equation number 1, equation number 1 is this. So if we put f equal to 1 in equation number 1, then equation become modified as 1 equal to 3 into n minus 1 minus 2p. Then we can rearrange that, and it will be 2p minus 3n minus 1 plus 4 equal to 0. This is known as Gabler's criterion. That is for single degree of freedom joints. That is Gabler's criterion. So these are the two criterion which is used for determining the degree of freedom of a mechanism. That is the two things. Next, that's another concept. This was also very important. That is m means mobility. This m equal to 0 for any mechanism. That means what is that means the mechanism cannot move. That is it is stationary, or motion is impossible. That is, system has enough constraints at the joints necessary to ensure equilibrium. That is first one. So if m greater than or equal to 1, that forms a mechanism. That means m greater than 1 or equal to 1 means mobility is there. M is mobility. Mobility is there means that forms a mechanism. Then if m equal to minus 1, so when we calculate the value of it to become minus 1, then what does it mean? It is statically indeterminate structure. So the questions may be asked like, what is statically indeterminate structure? Then you have to say if m equal to 1, that is mobility or degree of freedom is minus 1, that means that is statically indeterminate. That is means links have more constraints than are needed to maintain equilibrium. So this is also important. What is m, or means mobility or degree of freedom. Okay, now we will see some problems to calculate the degree of freedom of different mechanisms. So we will solve few problems, and you solve that few problems, the concept of degree of freedom will be clear to you. So in the next section we will solve some problems. So thank you for watching. So next section will be the problems. So see you with the problems on degree of freedom.